Hello friend, today in this video I am going to talk about mechanism of enzyme action. This topic belongs to Unit 2 PG 3rd semester Bioorganic Molecule. You know one scientist, Michael's Menten. So according to Michael's Menten hypothesis, enzyme molecule first combine with a substrate molecule to form an enzyme substrate complex, which further dissociate to form product and enzyme back. Means enzyme are biochemical catalysts involved in the chemical transformation of a specific compound or a group of compound. It has been established enzyme activity depends upon the presence of various metals. The metal in an enzyme is present as a chelate. On the basis of the ease with which metal can be removed from the enzyme, Valley designated them first one metalloenzyme inert complex, in which the metal does not leave the enzyme easily, even in the presence of large amount of good coordinating agents. And the second metal enzyme complex, labile complexes, from which the metal can be removed easily. So the former involves a specific metals and analogs complex with the different central metal ion having similar charge and size. Whatever I am talking, this is all term you know in coordination chemistry, but we are focusing on the bioorganic point of view. You know, which do not behave catalytically in the same manner. In the metal enzyme complex, the metal requirement is usually of more general nature and may be satisfied by a range of ion having similar charge and size. Thus, magnesium 2 and manganese 2 are often both effective as an activator of many enzymes. So, metal ions which are found in various enzyme systems are iron, copper, manganese, zinc, magnesium, molybdenum and calcium. मेरे दोस्तों, आप ये जानते हैं कि जब भी कोई रिएक्शंस आपने लिखा होगा तो एंजाइम प्लस सबस्ट्रेट तो एंजाइम और इस कॉम्प्लेक्स बनता है, फिर ये टूट करके आपका प्रोडक्ट देता है. तो ये सभी जो है वो एक तरह का प्रॉब्लम सॉल्व नहीं करता. उसके लिए दो तरह के आपने कॉम्प्लेक्स पढ़े होंगे, एक इनर्ट कॉम्प्लेक्स पढ़ा होगा, एक लेबाइल कॉम्प्लेक्स पढ़ा होगा. I am not going to deep in inert complexes, but I would suggest go to the inorganic chemistry and just read what is the meaning of inert complexes and labile complexes. तो कहने का मतलब है कि ये मेटल कैसे इंजाइम का फंक्शंस करता है, जिस मेटल में ये बहुत सारा चीज़ें हैं जैसे मॉलिब्डेनम है, कैल्शियम है, मैग्नीशियम है, जिंक है. तो ये सब आप पढ़ेंगे, फर्स्ट नोट बनाकर सेवरल टाइम्स आप रीड करेंगे तो बहुत सारी चीज़ खुद क्लियर होगी. Now, transition state theory. This theory is also known to you. Formation of enzyme substrate intermediate complex during enzyme activity in physiological system is very complex, and precise mechanism of this interaction is almost unknown. It is reported that the activity is a combination of steric, electronic, pharmacokinetics factors, and it could be understood in the light of chelating theory. अब चिलेटिंग के लिए आप फिर आई वुड से कि आप कोऑर्डिनेशन केमिस्ट्री पढ़िए, चिलेटिंग एजेंट सबको पढ़िए, बाइडेंटेट, ट्राइडेंटेट, टेट्राडेंटेट, है ना. सो पार्टिसिपेशन ऑफ द स्पेसिफिक मेटल आयन ड्यूरिंग इंटरमीडिएट कॉम्प्लेक्स फॉर्मेशन irrespective of whether a metal ion forms the integral part of the active site of the enzyme or enzyme required the metal ion as a cofactor for its activity. Mixed ligand complexes involving metal ion, enzymes and substrate are formed in the most enzyme reaction. Friend, the specific role played by a metal ion in an enzyme creation is often difficult to elucidate due to the complex nature of the protein structure. Now, model studies which relatively simple molecules of known structure often yield valuable information that give clues to the roles of metal ion in many enzymatic reactions. Metals are supposed to serve two purposes. First, provide proper stereochemical orientation, or second, bring reacting molecules, the enzyme and substrate closer so that the reaction may occur. So, the probable mechanism have been proposed to explain the mode of action of enzyme. My friend, you know the metal ion M forms complex with protein part of the enzyme E, apoenzyme, and forming the active enzyme EM. I told you just like the formation of ES, so here enzyme EM. So the active enzyme react with the substrate to give the intermediate. E plus S is equal to S. Now E plus M is equal to EM. Now just consider equation number 1. So enzyme metal substrate complex EMS, which subsequently decompose into product P derived from the substrate and the active enzyme. You can see this substrate forming this, and after that again EM, this one, and P. The metal, now second, metal form complex with the substrate first. The metal substrate complex MS first. They react with the enzyme to give the enzyme metal substrate complex, which subsequently decomposes into the product. The enzymes and the metal, that is M plus S, give the MS, plus E plus MS is give EMS, plus EMS give the P plus E plus EM. So now equation 6 becomes. So each step have the significance. Nothing is new, all you know, but just apply on the basis of bioorganic system. Now in third step, enzyme react with the substrate to form enzyme substrate complex, ES, which then combine with the metal ion to form enzyme substrate metal complex, ESM, and this ESM decompose subsequently to furnish the products. So you can see the up to 9 equations. I think it is very clear to you. Now, out of these 3 mechanisms, the first is followed by the most metal enzyme complex system. It finds support in the kinetic studies and in the determination of equilibrium constant for the complex involved. The second mechanism, although less commonly reported, is followed in a number of cases. Inorganic pyrophosphatase and hexokinase and creatine phosphokinases, all are enzymes. And the enzyme is often inactive towards simple derivative of this substrate. In many cases, the simple replacement of hydrogen atom by a methyl group completely blocks the reaction. The elucidation of the chemical mechanism by which enzyme catalyze reaction is a difficult problem. The most commonly used theory for providing a detailed mechanism in these reactions is the polyaffinity theory of Bergman, which may be summed up as enzymes interact with the multiple site on the substrate. Now, Kelvin emphasized, this is one scientist, emphasized the suitability of the coordinating process for furnishing this second kind of action. Involvement of metal complex in the enzyme reactions was pointed out by Hellman, and Smith postulated the formation of mixed complexes as intermediate. In the metal activated enzyme reaction, Smith worked on the leucine aminopeptidase and pointed out that the enzyme functions through formation of magnesium 2 plus and magnesium 2 plus activated complex. For example, glycyl L-leucinamide form manganese 2 complex activated enzyme leucine aminopeptidase complex as shown. You have the apoenzyme, you have manganese, and you have this substrate. This is the complex. Now, the orientation in steric effects. So, orientation in steric effect I will talk in next video, because already this is longer, it become longer. So, I will stop here. Thanks for watching, and if you like this type of video, then share it in your friend circle